Hello everyone, this is R. Bindushree studying in 8th SEM ISC from Sri Venkateswara College of Engineering. Today I am here to give seminar presentation on fraud detection in banking data by machine learning techniques under the guidance of Guru Prasad Vaike, Assistant Professor, Department of ISC. So these are the contents of today's topic: introduction, related background, working, future enhancement, conclusion, and references. Coming to introduction, as technology advanced and e-commerce service expanded, credit card becomes one of the most popular payment methods, resulting in an increase in the volume of banking transactions. Furthermore, the significant increase in fraud requires high banking transaction cost. Along with credit card development, the pattern of credit card fraud has always been updated. There are two mechanisms: fraud prevention and fraud detection. Fraud prevention is a proactive method that stops fraud from happening in the first place. Next is fraud detection. Fraud detection in banking is considered a binary classification problem in which data is classified as legitimate or fraudulent because banking data is large in volume and with datasets containing a large amount of transaction data. Manually reviewing and finding pattern for fraudulent transaction is either impossible or takes a long time. Therefore, machine learning algorithms plays an important role in fraud detection and prevention. Machine learning algorithms and high processing power increase the capability of handling large datasets and fraud detection in a more efficient manner. Machine learning algorithms and deep learning also provide fast and efficient solutions to real-time problems. Next comes the related background. Author P. Verma and P. Tyagi, they proposed analysis of supervised machine learning algorithm in the context of fault detection. The work says that they investigated the study of machine learning algorithm to identify the best supervised machine learning based algorithms. Next comes the author A. Godavarti, A. R. Kota, and E. Sase. They proposed analyzing credit card fraud detection based on machine learning models, which says that as the online shopping is blooming, it helps in rendering the cashless payment models like paying rent, paying internet bills, etc. Using for all these things, there is a chance of fraud transaction for a credit card. Hence, there is a more risk. Next comes the author Vipul Jain, H. Kavita, S. Mohana Kumar. They proposed credit card fraud detection web application using Streamlit and machine learning, which says that to detect the fraud transaction within this datasets, three machine learning algorithms are used and compared. The machine learning algorithms based on their accuracy and MCC score. Coming to working, this is the flowchart followed in credit card fraud detection. First is raw data. Next comes the data pre-processing. In data pre-processing, there are two features. One is extraction and selection. After that, we split the data into training and testing. Next comes the Bayesian optimization. After that, we apply algorithms and five-fold cross-validation. Next, model evolution is done based on accuracy, precision, recall, F1 score, MCC score. Step 1, datasets. The datasets contains only numerical input variable resulting from a principal component analysis transformation. Let us consider a dataset named credit card that contains 2,84,807 records of 2 days of transaction made by credit card holders. There are 492 fraudulent transactions and the rest of the transactions are legitimate. The positive class accounts for 0.172% of transaction, hence the dataset is highly imbalanced. Next, step 2 is data preprocessing. In this, there are two features, one is extraction and selection. As the table shown, the total number of fraudulent transactions is significantly lower than the total number of legitimate transactions, indicating that the data distribution is imbalanced. Feature extraction. The time feature includes the time elapsed between each transaction and the first transaction. To make the most of the features, we expand it to extract the transformation har feature, which gives us more information than the time feature itself. Next comes the feature selection. The features are unknown except the time and the amount, and we don't have any additional information. Feature selection tries to find a subset of features that improves the classifier's performance on efficiently detecting credit card fraud. Next, algorithms. In this, we have used 6 algorithms. One is logistic regression, light GBM, XGBoost, CatBoost, majority voting, and deep learning. Hyperparameters have a significant uh, effect on the performance of machine learning models. Optimization has the process of finding the best set of hyperparameters that configure a machine learning algorithms during its training. So the Bayesian method is capable of finding the optimized value in a much smaller number of training cores compared with others optimized methods. First is logistic regression. Logistic regression is the predictive analysis that finds out if two or more variables are related to each other. This method determines whether there is a relationship between one binary dependent variable and one or more ordinal, nominal, interval, or ratio level independent variables. These algorithms could not be used for unbalanced data. Next is light GBM. Light GBM algorithms is built on the GDBT framework and aims to improve computational efficiency, particularly on big data prediction problems. The high performance light GBM algorithm can quickly handle large amount of data and the distributed processing of data. Next comes the XGBoost. XGBoost stands for Extreme Gradient Boosting. The XGBoost has become a dominant algorithm in the field of applied machine learning. XGBoost is a type of decision tree algorithms with boosted gradients. Next comes the CAT boost. After that, majority voting, which is a type of machine learning, combines several classifiers, minimize the error of the classifiers, and achieves more reasonable result than a single technique. A voting majority classifier is not a real classifier but a method that is trained and evaluated in parallel in order to use the different features of each algorithm. Next comes deep learning. Deep learning algorithms are a class of machine learning algorithms where multiple hidden layers are used to improve the outcome. Deep learning is shown to be a very promising solution to deal with fraud and in financial transaction, making the best use of banks big data. Deep learning is a generic term that refers to machine learning using a deep multi-level layer artificial neural network. Next comes the evaluation matrix. We apply a cross-validation test to evaluate the performance of the proposed model for the credit card fraud detection. We use this stratified five-fold validation test to obtain a reliable performance comparison in the unbalanced set. We use the common metrics for our evaluation, including accuracy, recall, precision, FN score, MCC, which stand for Matthew correlation coefficient, and AUC diagram. Positive number represent fraudulent transaction and negative number represents legitimate ones. The TP, which stands for true positive, represent fraudulent transaction that has been classified and FP, which is false positive, indicates the number of legitimate transaction misclassified as fraudulent. The true negative TN represents a legitimate transaction classified as legitimate, and the false negative FP in FN indicates the misclassified fraudulent transaction as legitimate. These are the mathematical expression for the matrices used, and accuracy. Accuracy quantifies the total performance of the classifier and is defined as the number of correct prediction made by the model. When dealing with data that is not balanced, this does not give good result because it also gives a high value if even one fraudulent transaction is found. Recall shows the efficiency of the classifier in detecting actual fraudulent transaction. Next is precision. Uh, Precision measures the reliability of the classifiers, and the F1 score is the harmonic average of recall and precision measure that consider both false, negative, and positive. There is a good way to describe the true and false positive and negatives using one indicator. One good solution is to use MCC, which measure the quality of the two classes problem taking into account the true and false positive and negatives. It is a balanced measure, even when the classes are of different sizes. Next comes the future enhancement. For future studies and work, by using other hybrid models as well as working specifically in the field of cat boost by changing more hyperparameters, especially the hyperparameters number of trees. Also, due to hardware limitation, the use of stronger and better hardware may bring better results that can ultimately be compared with the result of the study. Coming to the conclusion part, the credit card fraud detection problem in real unbalanced datasets, we used a publicly variable credit card datasets. The assurance of the result of MCC for unbalanced data provide that compared to other criteria of evaluation is stronger. And also by combining the light GBM and XG boost methods, we obtain 0.79 and 0.81 for the deep learning method. Using hyperparameters to address data unbalanced compared to sampling methods, in addition to reducing memory and time needed to evaluate algorithms, also has better results. So, coming to the references, these are the papers which I have referred for my technical seminar. That's all. Thank you for watching.